Calculating the load for service conductors supplying air conditioning units involves several steps according to the National Electrical Code, specifically NEC Articles 430 and 440. Let's consider an example of a dwelling unit with a 230-volt, 15 horsepower, 3-phase air conditioning compressor motor connected to a 60-amp branch circuit, along with 4 one-ton split system air conditioners with condensing units rated at 115 volts single phase and 15 amps each. Our goal is to calculate the total load for the service conductors supplying these 5 air conditioning units. Firstly, we'll calculate the branch circuit load for the compressor motor. Secondly, we'll calculate the load for the 4 split system air conditioners. Finally, we'll determine the total load for the service conductors. For the compressor motor, we need to determine the full load current, often referred to as IL, from NEC Table 430.148. This table provides full load currents for 3-phase alternating current motors. Using the service voltage of 230 volts and the motor horsepower of 15 horsepower, we find that IL equals 61.4 amps. Next, we calculate the branch circuit current IC using the formula IC equals IL multiplied by 1.25 as per NEC 430.22. This section addresses conductors supplying a single motor used for continuous duty. Therefore, IC equals 61.4 amps multiplied by 1.25, which equals 76.8 amps. Furthermore, we increase IC by 25% as required by NEC 440.6a, since the motor load is more than 1 horsepower. This section pertains to air conditioning and refrigerating equipment motor compressor loads. Thus, IC equals 76.8 amps plus 25% of 76.8 amps, resulting in IC equaling 96 amps. Now let's calculate the load for the 4 split system air conditioners. We'll start by determining the full load current IL from NEC Table 430.150. This table lists full load currents for single-phase alternating current motors. Given the service voltage of 115 volts and knowing these are single-phase motors, the full load current IL is 15 amps per unit. To find the total full load current for all 4 units, we multiply IL by the number of units. Therefore, IL equals 15 amps multiplied by 4 units, resulting in 60 amps. To determine the total load for the service conductors, we sum the load for the compressor motor and the load for the 4 split system air conditioners. The total load equals 96 amps plus 60 amps, which equals 156 amps. Finally, we need to determine the minimum allowable ampacity of the service conductors, consulting NEC Table 310.16 and Table 310.15b16. These tables provide ampacity ratings for insulated conductors. Based on our calculation of 156 amps, the service conductors must have an ampacity of at least 156 amps. Considering standard conductor sizes and ampacity ratings, we would typically select conductors with an ampacity of 150 amps or higher, depending on the specific conductor type and installation conditions. In conclusion, the service conductors must have an ampacity of at least 156 amps to safely carry the load of the 5 air conditioning units. This calculation ensures that the electrical system is properly sized to handle the demands of the connected equipment, maintaining safety and preventing overloads. Note that while the handbook says at least 150 amps, that is incorrect. It must be at least 156 amps. Remember to always consult the latest edition of the NEC and local amendments for the most accurate and up-to-date requirements.